Good afternoon, everyone. In last class, we have learned about by parts method. Okay, so today we will do some question on by parts method. We try to solve exercise 7.6. So the question number one is we have to integrate the function x sin x. So there is two function. First one is x and second is sin x. X is an algebraic function and sin x is our trigonometric function. So we have to integrate integration of x sin x dx. You have sometimes try to solve. So the answer is minus x cos x plus sin x plus c. Let's go to the solution part. To integrate x sin x, you use the concept of integration by parts. Okay, so the formula is u dv equal to ub minus integration of v du. The last class we read the formula as integration of fx dx is equal to fx integration of gx minus integration of differentiation of fx into integration of gx. But here it is right as integration of u dv equal to uv minus integration of v du. So the u as take as you can take as fx and dv can be taken as gx dx. So at first we take fx as u and into v, that is integration of dv minus integration v, that is integration of gx into differentiation of fx. So the both formula is same. It is just a short form. So we choose u x as u and sin x dx as dv. We choose by the rule that is called elate rule. Elate means one I for inverse, L for logarithmic function, A for algebraic, T for trigonometric, and at last exponential function. Since the algebraic function come first, then trigonometric, so we take x as u and sin x as v function. To get now we substitute the value of u and v. So you have to find the value v and we have to also find the value of du. To find v, we just integrate dv, and to find du, we have to differentiate u with respect to x. So now we find du by differentiating u and v by integrating dv. So when we differentiate u equal to x, we get dx by dx, that is 1. So du is equal to 1 into dx. Now we have to find the value of v, so we just integrate dv, and the dv is sin x dx. So when we integrate dv, we get integration of sin x dx, that is v is equal to minus cos x, because the integration of sin x is minus cos x. So now we have the value of du and v. So just substitute into the formula of integration by parts. So we get integration of x sin x dx is equal to uv minus integration of v du. So in place of u we put x, and in place of v, that is minus cos x, and in place of du, that is 1 dx. So when we simplify the expression, the integration comes minus x cos x minus integration of minus cos x dx. So it become minus x cos x plus integration of cos dx and integration of cos x sin x. So the final answer is minus x cos x plus sin x plus c. Therefore, the integral of x sin x is minus x cos x plus sin x plus c. So, to integrate such kind of integral, we have to choose first which function we want to take as u and which function we want to take as dv by the method of by the Ellet rule. And then we have to find the value of du by differentiating u, and we have also find the value of v that we can get by the integrating dv. Let's go to the next question. So at first you try. Okay. So the answer is minus x cos 3x by 3 plus 1 by 9 sin 3x plus c. To integrate the function x sin 3x, we use the integration by parts formula. And for that, we have to choose u and dv. Here, the same as the question number 1, x is algebraic function and sin 3x as a trigonometric function. And as in Ellet rule, algebraic function comes first. So we take x as u and sin 3x take as dv. Sin 3x dx is take as dv. So u is equal to x and dv is equal to sin 3x dx. To substitute this value into integration by parts formula, at first we have to differentiate u and integrate dv so that we can get du and v. So at first we differentiating du, that is again 1, that is du is equal to 1 dx, and to get v we integrate dv. So integration of sin 3x dx. To integrate sin 3x, we use a substitution method. What is substitution method? We substitute ax as some other variable and then convert this integral into integration of other variable, where we can directly apply the standard formula, that is integration of sin x is minus cos x. So take 3x as w. When we differentiate it with respect to x, we get dw is equal to 3 dx. So dx is equal to 1 by 3 dw. So we can substitute into the integration of sin 3x. In place of x, we substitute w by 3, and in place of dx, we put 1 by 3 dw. So it comes sin w 1 by 3 dw equal to 1 by 3, and integration of sin x is minus cos. So it minus cos w. So the integral is minus 1 by 3 cos 3x. Just substitute back the value of w, that is 3x. Now we have v, that is minus cos 3x by 3. and we also have the value of du, that is 1 dx. So just substitute this into the integration by parts formula. So integration is equal to uv minus integration of v du, that is x into minus cos 3x by 3 minus integration of minus cos 3x by 3 into 1 dx. Here the value of v is minus cos 3x by 3 and the value of du is 1 dx. And the value of u is x. So when we simplify, we get minus x cos 3x by 3 minus integration of minus cos 3x by 3 dx. Constant comes out and it become 1 by 3 integration of cos 3x dx. So now we again apply the substitution method on the integration of cos 3x dx. And as we apply on sin 3x, in similar way, when we integrate cos 3x, we get sin 3x by 3. Using the general formula, that is whenever we integrate cos ax dx, we get 1 by a sin ax plus c, that is a constant of integration. So the value of integral is minus x cos 3x by 3 plus 1 by 3 sin 3x by 3 plus c. So I equal to minus cos 3x by 3 plus 1 by 9 sin 3x plus c. Therefore, the integral of x sin 3x is this. You understand? Okay. So till now, we see how we can apply by parts method to integrate multiple of two functions. At first, we have to choose which function we take as u and which function we take as dv. And to get du, we differentiate u, and to get v, we integrate dv. And then substitute into the by parts formula, do the simple calculation where we have to find some integration, and then we simplify it and we get the original integrate. So now the third question is integrate the function x square ex. The first function is algebraic and second function is exponential. So think which function we have to take as u and which function we have to take as dv. So the answer is ex into x square minus 2x plus 2 plus c. Let's go to the solution. By using by parts, what we do, we just break the given integral into a smaller parts of integration so that we can integrate. Integration is by parts, not any kind of shortcut, so that we can integrate directly. We just integrate. Integrate by doing it into the parts. We just small. So now we have to integrate x square into ex. So we use the integration by parts formula. It might be possible that when we calculate integrate by the integration of parts, we have to apply integration by parts multiple times, as we have to apply the integral by parts multiple times in this question. So the formula is integration u dv is equal to uv minus integration v into du. So now, which function we take as u? That is x square, and exponential function is take as dv, because in Ellet rule, algebraic comes first and exponential comes in the last. So u is take a, we can take u as fx, that is u equal to x square, and ex dx is take as dv. So now we have to find the value of du and v. So to find the value of du, we just differentiate the function u with respect to x, and differentiation of x square with respect to x is 2x. So we get du is equal to 2x dx. And to find v, we integrate dv. So integration of ex is again ex. Integration of exponential x is again exponential x. So now we have the value of du and v. So just substitute this into the integration by parts formula. So integration of x square ex dx is equal to uv minus integration of v du. So u is x square and the value of v is ex minus integration of v, that is ex, into du, that is 2x dx. Just simplify, we get x square ex, the constant comes out of integration, so minus 2 integration x ex dx. So now we need to find the value of integral x ex dx, and that is also a multiplication of two functions. First function is x and second function is ex. So we have to apply by parts on x ex. So x can take as u and ex as dv by the Euler rule. So we have to find value of du just by differentiating u with respect to x. So du by dx is equal to dx by dx. So du is 1 dx. And to get v, we have to integrate dv, and integration of ex dx is v equal to ex. So when we substitute this into the integration by parts formula, we get x ex minus integration of ex into 1 dx. So when we simplify it, we get x ex minus ex. So the integration of x ex is x into ex minus ex. Now substitute the value of integration of x ex into the equation of integration of x square ex. So we get integral equal to x square into ex minus 2 into x ex minus ex plus c. That is, factor out ex from the terms, we get I equal to ex into x square minus 2x plus 2 plus constant of integration. So in this question, we have to apply by parts method 2 times. So it might be possible to integrate multiplication of two functions. We have to apply integral by parts multiple times. Now, the fourth question is integrate the function x log x. So just try. So the answer is x square log x by 2 minus x square 4 plus c. Okay, so solution part. To integrate the function x log x, we apply by parts. And now And now the question is which function we take as u and which function we taken as dv. So just recall the elect rule. In elect, algebraic function that is x come first. In elect, the logarithmic function come first, then algebraic. So now we take log x as fx and x as dv, because in elect the first one, the log x is first come first as logarithmic function and then come algebraic function. So now we take log x as u and the algebraic function x as dv. Now the problem is we have to find the value of du and v. When we know the value, when we find the value of du and v, we just substitute into the by parts formula. So when we have to find the integral by using the by parts, the original problem is to find which function we have to taken as u and which function we have to take as v. So for u, we differentiate with respect to x, we get differentiation of log x is 1 by x. So we get du is equal to 1 by x dx. And to get v, we integrate dv. So integration of dv is equal to integration of x dx. And integration of x is x square by 2. We know whenever we integrate x to the power n, the integral value is x to the power n plus 1 by n plus 1. Now substitute these into the integration by parts formula. So the value of u is log x, the value of v is x square by 2, and the value of du is 1 by x dx. Simplify the expression, we get x square log x by 2 minus integration of x square 2x dx. So we get x square log x by 2 minus x cancel out, integration of x by 2 dx. Integrate the term x by 2 dx. Constant comes out 1 by 2 integration of x dx, that is 1 by 2 into x square by 2, that is x square by 4. Combining the result, we obtain the integral of x log x is x square log x by 2 minus x square by 4 plus c. That is the solution of the integral of x log x. You understand? Now we have the another question number 5, that is we have to integrate the function x log 2x. So just think as the question number 4, which function we have to take as u and which function we should have to take as v, dv. So answer is x square log 2x by 2 minus x square by 4 plus c. Let's go to the answer solution part. Now we have to integrate x log 2x and we use the integration by parts formula. So we have to choose u and v. u and dv. And as we know, in the Elliott rule, logarithmic come first. So we take log 2x as u and algebraic as dv, that is x dx. Now we have to find the value of du and v. To find the value of du, we just differentiate u with respect to x. So when we differentiate log 2x with respect to x, that is d log 2x by dx. Now we apply the chain rule. At first we have to differentiate log 2x, that is 1 by 2x, and then according to chain rule we differentiate 2x, that is 2. So we get 2 by 2x. So the original answer is 1 by x dx. You should know the chain rule to differentiate log 2x. So du is equal to 1 by x dx. Now to find the value of v, we just integrate dv. So integration of x dx is v is equal to x square by 2. We apply the formula of integration of xn, that is xn plus 1 by n plus 1. Now substitute this into the integration by parts formula. We know the value of u, that is log 2x, v, that is x square by 2, and du, that is 1 by x dx. Simplify this. We get x square log 2x by 2 minus integration of x square 2x dx. So x square log 2x by 2 minus x cancel out, so it comes x by 2 dx. The final integrate. So finally we have to integrate integration of x by 2 dx. So the constant term comes out of the integration. So 1 by 2 integration of x dx. And the integration of x dx is x square by 2. So this is equal to x square by 4. So combining the result, we obtain integration is equal to x square log 2x by 2 minus x square by 4 plus c. Therefore, the integral of x log 2x is x square log 2x by 2 minus x square by 4 plus c. Now we do the question number, go to the question number 6. In 6, we have to integrate the function x square log x. So just think which function we have to take as u and which function we should have to take in as dv. The answer is x cube log x by 3 minus x cube by 9 plus constant of integration, that is c. Let's go to the detailed solution. We have to apply, you use the integration by parts formula. So we have to choose u and dv. To choose u and dv, we apply the Elliott rule. And according to the Elliott rule, logarithmic function come first. So log x is taken as u and x square dx is taken as dv. So now to use the formula by parts, we have to find the value of du, that is differentiation of u function, and the value of v, that is integral of dv. So we differentiate u with respect to x. So du by dx is equal to d log x dx, and differentiation of log x is 1 by x. So du is equal to 1 by x dx. And to find v, we just integrate dv. So integration of x square dx is equal to v equal to x cube by 3. Here the value of n is 2. That is integration of xn is xn plus 1 by n plus 1. So the integration of x square is xn plus 1, that is 2 plus 1, 3 by 2 plus 1, that is 3. So now we have the value of v and du. Substitute this into the integration by parts formula. The value of u is log x. For v, we substitute x cube by 3. Then integration minus integration. And the value of v is x cube by 3 into the value of du, that is 1 by x dx. Now we simplify it, we get x cube log x by 3 and integration of x cube by 3x dx. X cancel out in the second term. So we get x cube log x by 3 minus integration of x square by 3 dx. So to get the final answer, we have to integrate x square by 3. And integration of x square by 3 dx is equal to 1 by 3 constant terms comes out of the integral, and then integration of x square, that is integration of x square is x cube by 3. So 1 by 3 into x cube by 3, that is x cube by 9. Combining the result, we obtain x cube log x by 3 minus x cube by 9 plus c, that is constant of integration. Therefore, the integral of x square log x is x cube log x by 3 minus x cube by 9 plus c. The seventh question is, we have to integrate the function x sine inverse x. And now here, one function is algebraic and the second one is inverse trigonometric. So think about the Euler rule and which function we should have to take in as u and dv. So the answer is 1 by 4 2x square minus 1 sine inverse x plus x by 4 into root under 1 minus x square plus constant of integration. So we apply the integration by parts to integrate this, and the formula is integral of u dv is equal to uv minus integration of v du. So we need to choose u and dv, and we apply Euler rule. And in a Euler, the inverse function comes first. The first one, that is the Euler, I for inverse, and then algebraic. So we take sine inverse x as u and x as dv. So u is equal to sine inverse x and dv is equal to x dx. Now we have to find the value of du and v. To get du, what we do? We just differentiate u is equal to sine inverse x. And to get the value of v, we just integrate dv. So at first we differentiate u with respect to x. So differentiation of sine inverse x is equal to du is equal to 1 by root under 1 minus x square dx. This is a formula, that is the differentiation of sine inverse x is 1 by root under 1 minus x square dx. We already done this into the chapter of differentiation. When we integrate dv, that is integration of x dx, is v is equal to x square by 2. Substitute this into the integration by parts formula. The value of u is sine inverse x, v is x square by 2, and du is 1 by root under 1 minus x square dx. Now we simplify it. So the first term is x square sine inverse x by 2, and the second term is 1 by 2, that is a constant term. Integration of x square root under 1 minus x square dx. Now we have to find the value of this integral. To simplify this integral, we used an algebraic manipulation in the numerator. Because the degree of the numerator and denominator is same, so you use this type of manipulation. That's why you use this type of manipulation. So we add -1 and +1 to numerator, we get minus into 1 minus x square, that is same as the denominator. So when we separate the plus sign, the first term get cancel out. So we get minus 1 by x square divided by square root of 1 minus x square plus 1 by square root of 1 minus x square. So when we cancel out the square root, we get minus square root of 1 minus x square plus 1 by square root of 1 minus x square. So the integral become integration of first term, that is minus 1 by x minus x square plus integration of 1 by integration of 1 minus x square. And now this is a standard form of integration. We know the value of this integral. The first form is standard integral formula, that is integration of root under a square minus x square dx is equal to x by 2 square under square root a square minus x square plus a square by 2 sine inverse x by a plus c. And the second standard integral formula is integration of 1 by a root under a square minus x square dx is equal to sine inverse x by a plus c. So for our case, a is equal to 1. So the integration of 1 minus x square, just substitute the value of a, that is a is equal to 1, into standard integral formula. So we get x by 2 under square root 1 minus x square plus 1 by 2 sine inverse x, and integration of 1 by root under 1 minus x square dx is equal to sine inverse x. Substitute this back into the expression for integration of x square root under 1 minus x square dx, that is minus x by 2 root under 1 minus x square plus 1 by 2 sine inverse x plus sine inverse x. So it become minus x by 2 root under 1 minus x square minus 1 by 2 sine inverse x plus sine inverse x. Simplify it, we get minus x by 2 root under 1 minus x square plus 1 by 2 sine inverse x. Now this is a value of the integral x square by 1 root under 1 minus x square dx, not the original solution, final solution. To get the final solution, we substitute this value of integral into the equation 1. So the final integral become x squared sine inverse x by 2 minus 1 by 2 into minus x by 2 root under 1 minus x square plus 1 by 2 sine inverse x plus c. So just simplify it. Group the terms with sine inverse x. We get I is equal to x square by 2 minus 1 by 4 sine inverse x plus x by 4 root under 1 minus x square plus c. Combining the coefficient of sine inverse x, just simplify it. We get the integral value of x sine inverse x is 1 by 4 2x square minus 1 sine inverse x plus x by 4 root under 1 minus x square plus c. Done. So the question number 8 is we have to integrate x tan inverse x. Same as question number 7. Here, one is algebraic function, another is inverse trigonometric function. So in a similar way, we know which function we have to take as u and which function we should take as dv. Okay, okay. So try. So the answer is x square by 2 tan inverse x minus x by 2 plus 1 by 2 tan inverse x plus c. Till now we know how we should apply integration by parts, what is the formula of integration by parts, and how we should choose u and dv by the Ellet rule. So by the Ellet rule, as inverse trigonometric function come first, so we take as u, and then algebraic. So we take x dx as dv. Now in the same manner, we have to find the value of du and v. To get du, we differentiate u with respect to x. So differentiation of tan inverse x is 1 by 1 plus x square. Now we have to integrate dv, that is integration of x dx, is x square by 2. Substitute this into the integration by parts formula. We get integration of x tan inverse x dx, that is uv minus integration of v du. So tan inverse x into x square by 2 minus integration of x square by 2 into 1 by 1 plus x square dx. To just simplify it, we get x square tan inverse x by 2 minus 1 by 2 integration of x square by 1 plus x square dx. Now we need to evaluate the new integral, integration of x square by 1 plus x square dx. So degree is same, so just we use an algebraic manipulation so that the function is distributed into two parts. So just add plus 1 and minus 1, we get x square plus 1 by 1 plus x square minus 1 by 1 plus x square. The first term is cancelled out. In the numerator and numerator, both are same. So we get x square by 1 plus x square is equal to 1 minus 1 by 1 plus x square. So the integral become x square by 1 plus x square dx is equal to integration 1 minus 1 by 1 plus x square. So integration of 1 dx minus integration of 1 by 1 plus x square, that is a standard form, and we know the value of this integral. Integration of 1 dx is x and integration of 1 by 1 plus x square is tan inverse x. Integration and differentiation are inverse of each other. So we know that the differentiation of tan inverse x is 1 by 1 plus x square. So integration of 1 by 1 plus x square is tan inverse x. To substitute this back, we get integration of x square by 1 plus x square is x minus tan inverse x. So the final integral is x square tan inverse x by 2 minus 1 by 2 into x minus tan inverse x plus c. Let's simplify. And also factor out 1 by tan inverse x. So the final integral is x square by 2 tan inverse x minus x by 2 plus 1 by 2 tan inverse x plus c. The question number 9 is we have to integrate the function x cos inverse x. So just think about this question. The answer is 2x square minus 1 by 4 cos inverse x minus x by 4 root under 1 minus x square plus c. Apply the by parts method. The integration of u dv is uv minus integration of v du. Now we need to choose u and dv. And as we know, inverse trigonometric function come first. So we take it as u, that is u is equal to cos inverse x. And for dv, we take x dx. Now we need to find the value of du and v. And for that, we differentiate u with respect to x. So du is equal to, du, the differentiation of cos inverse x, that is minus 1 by root under 1 minus x square. So the value of du is minus 1 by root under 1 minus x square dx. And to get the value of v, we integrate dv. So integration of x dx is x square by 2. Now substitute this into the integration by parts formula. For u, we put cos inverse x. For v, x square by 2. And same, we just substitute the value of v and du. Now simplify the expression, that is x square cos inverse x by 2 plus 1 by 2 integration x square by 1 minus x square dx. Now we need to evaluate new integral x square by root under 1 minus x square dx. Simplify the integral. We use the algebraic manipulation in the numerator. So we get, just add 1 and minus subtract 1. So minus 1 minus x square plus 1 by root under 1 minus x square. Separate the division. So we get minus 1 minus x square divided by root under 1 minus x square plus 1 by root under 1 minus x square. So that we get minus root under 1 minus x square plus 1 by root under 1 minus x square. Now apply the integral both sides. So j become integration of minus root under 1 minus x square plus 1 by root under 1 minus x square dx. We apply algebraic manipulation so that the integral get converted into a standard form. Now we know the integration of root under 1 minus x square and integration of 1 by root under 1 minus x square. We use the standard integral formula, that is integration of root under a square minus a square dx is x by 2 integration of a square minus x square plus a square by 2 sine inverse x by a plus c. And second standard formula is integration of 1 by root under a square minus x square dx is sine inverse x by a plus c. Now for our case, the value of a is 1. So just put a is equal to 1 is to standard integral formula. We get the integral of 1 minus x square, that is x by 2 root under 1 minus x square plus 1 by 2 sine inverse x. And integration of 1 by 1 root under 1 minus x square, that is sine inverse x. Substitute this back into the expression for j. The value of j is minus x by 2 root under 1 minus x square plus 1 by 2 sine inverse x plus sine inverse x. Simplify it, we get minus x by 2 root under 1 minus x square plus 1 by 2 sine inverse x. That is not the final answer. This is not the integral of x cos inverse x. To get, we have to substitute this integral value into equation 1. So the final integral is x square cos inverse x by 2 plus 1 by 2 into minus x by 2 under the square root 1 minus x square plus 1 by 2 sin inverse x plus c. Distribute the 1 by 2. We know the integral trigonometric identity is that the sin inverse x plus cos inverse x is equal to pi by 2. So sin inverse x is equal to pi by 2 minus cos inverse x. So in place of sin inverse x, we substitute pi by 2 minus cos inverse x. So the expression is x square cos inverse x by 2 minus x by 4 root under 1 minus x square plus 1 by 4 into pi by 2 minus cos inverse x plus c. And that is the value of our integral. Grouping terms with cos inverse x, simplify it. We just enhance the appearing of solution. So combining the coefficient of cos inverse x, observe the constant pi by 8 into the arbitrary constant c dash, that is another constant pi by 8 plus c, it become now c dash. Therefore, the integral of x cos inverse x is 1 by 4 2x square minus 1 cos inverse x minus x by 4 root under 1 minus x square plus c.